Good morning, gentlemen. Let's talk a little bit about line of sight in Dan Lawrence's D&D and how it differs from line of sight in traditional roguelikes, and what kind of complications arise as a result. I'm still having my coffee, so please forgive me if I'm a bit slow. Oh, so slow I even dropped my pen. Just a minute. Oh, right under the desk as always. It never lands somewhere easy to pick up, does it? Yeah, let's get to rambling here, shall we, gentlemen and ungentlemen? All right. So, as you recall, in D&D, let's call it the viewport. Oh, come on, what's wrong with my camera? It's not focusing right, you piece of junk. As you recall, in D&D, the part of the map that you can see is 3x3 squares, dungeon cell. I hate to call them cells because you can't call dungeon locations. Let's call them locations. The part of the map that you can see in Dan Lawrence's D&D is a 3x3 grid of dungeon locations. And we'll call that 3x3 grid the viewport, for the purposes of this discussion, the part of the world that you can see. And we'll also use the same terminology when we're talking about roguelike games, which typically have a more of a grid map. Recall that in Dan Lawrence's D&D, each dungeon location has walls that are part of that location. It's not like the walls are made up of blocks that are filled in like they are in traditional roguelikes. So we could maybe let's sketch out what the entrance to Telengard might look like. There's an opening on the just a big opening on the west wall, and there is a wall right here with a secret door in it. And I'm trying to remember, there's a wall up here, because you can go off this direction up there, and this secret room has a dragon in it. How he got through that little secret door, I don't know, but we'll think about that some other time. And as I recall, there's a door down here somewhere. It may actually be over on this wall over here. I can't remember. So when you're standing in the entrance to Telengard, the player character is right there, right? So here's our here's the upper left corner of the viewport, right? And here's the lower left corner of the viewport, right? So we can see within this 3x3 area, but we can't see inside of this little secret room here. And if we were down here by this door, we wouldn't be able to see through that door. And the way that traditional roguelikes do this is that they'll start in the center of the screen and they'll cast a ray outwards in some direction, and if it just keeps going to the distance of the character's vision. But as soon as it hits something, as that ray is cast out through there, the cells that you can see are marked as visible, but as soon as that ray hits something, it stops. So if we were, for example, casting a ray up in this direction, it would go up here and hit this wall and stop, so we wouldn't be able to see what was in here. But if we cast it past the edge of this wall, we'd see halfway into this location. See, we'd have like a cone of view out this hole. And that's very easy in traditional roguelike games, because you've just got some blocks that are filled in here and there, right? And you've got the player character standing in the middle of the screen, and you just cast your rays and they either hit something or they don't. Right? You out to the edge of the vision. You just keep doing that. If you hit something, then you quit, and you can't see anything back here. You can't see anything back here, right? But that's a little more difficult in Dan Lawrence's D&D because these walls and the contents of the room and all that stuff is kind of like built in. It's all part of the room. There isn't any. Like the north and the west walls are different. Are two different bits within the map data, and it just turns into kind of a clusterfuck, really. But fortunately, in a limited set like this, a 3x3 grid with the player character standing in the middle, we can do it in a predictable way just for this, which actually ends up being faster than casting rays. So we'll look in all four cardinal directions. We'll try to. All right. First, and we can't see through here, right? But we can see into each of these other locations, right? And if we can see into one of these locations in the four cardinal directions, then we'll try to look in the two directions adjacent to it. So we'll try to look this way and discover that we can. We'll try to look this way and discover that we can't. We'll try to look that way and discover that we can. We won't do anything else down here because we've already decided that we can't see into this square. And we'll try to look both directions down here. Alright? So we can see into this space because we can see into this space. Right? If there were a wall here, for example, we wouldn't be able to see into this space. We wouldn't be able to see anything in there. We haven't been able to see anything in here because that ray got interrupted right there. You know what I'm saying? If there was a wall right here, for example, we wouldn't be able to see into this space. Right? So that ends up working pretty well for the limited use case of a 3x3 grid like this. But as in the future, as we expand the game, I'd like to increase this to a 5x5 grid, or perhaps even a 7x7 grid. It makes sense to not be able to see very far in a dark, dank dungeon, you know what I'm saying? And this works well for exploring dungeons. I got no problem with this, and the algorithm's very fast. But eventually, I'd like to have, like, overland areas that operate on the same sort of a map that connect the dungeons with each other. And when you're outside in the daytime, I think you should be able to see further. I think we should have a 7x7 or 5x5 grid for that. And when we expand this grid out to those sizes, this algorithm becomes quite complex fairly quickly in comparison to the raycasting that traditional roguelikes use. Now, it's worth noting that when we do this in code, we can write our code to just look in one direction, to try to look up and then look to the two sides. All right, and then we can store the directions that it's going to look as this will be like -1, or 0, -1, and this will be 1, -1, right? And then we can negate one or both of those values to look in the other directions, right? So we can write the code that does this pretty small. It doesn't have to be like big nested blocks of shit. We can actually do this fairly efficiently, I think. The problem comes in printing it, but we'll get to that later. So yeah, anyway, when we expand this to 5x5, things quickly become untenable. And I mean, you can, as you can imagine. I guess let's try to do this on a 5x5 grid, just for shits and giggles. Even though stuff may get complicated kind of fast. Alright, so here's the center cell where the player character is, right? So in the case of this 5x5 grid, we'll try to look in a direction. Alright. That's step one. We'll try to look in all the directions surrounding that as step two, using some kind of recursive function, most likely. But then, alright, then when we get to the next steps in this algorithm, we can't look back down. You can't see around these corners. You know what I'm saying? So when we go up for number 3, it has to look in these directions here only, and this direction, right? Because you can see around this way. Like that, right? And then when we try to look into this last corner, yeah, I guess both of these need to try to go in that direction for the 4th step. And, yeah, okay, maybe we shouldn't have tried to look down into number 3 here. But then, no, we have to. We have to, otherwise, yeah. See what I'm saying? This turns into a clusterfuck very fast. And being able to use this raycasting type algorithm, like we use in a traditional roguelike game, would make all of this a hell of a lot easier. But it gets too complicated to do it with this type of dungeon structure. So the best way that I can think of to try to do this is to redraw the map internally the way that it would be represented in a more traditional roguelike game that uses raycasting like that. So if you had, let's take this this dungeon entrance for example. We would have our cell that we're in. All right. Then we'll have a secret door over here with filled-in blocks on either side. Right. We have a wall up here. Alright, player characters right there. We have a door right here somewhere, as I recall. And then more walls like this, I think. There's not supposed to be a wall right there, but whatever. And we draw the map something like this. We've got our cell on our walls, and then we just cast our rays like we normally would out to the edge of the viewport. We'd try to cast one to here. We'd try to cast one to here. We'd try to cast one to here. To here, right? But these would get blocked by this wall and vice versa. And then we'd be able to see, we'd have to go back and if any of these cells within our intermediate representation were visible, then this whole this whole dungeon location would be visible. Likewise, if any of the cells in this part of the intermediate representation here were visible, then this whole dungeon cell would be visible, and vice versa, or that's not the right word to use in this context, because the walls are shared between the dungeon locations, you know what I'm saying? So it gets quite cumbersome, doesn't it? That won't be a very efficient way to do it, and finding a general solution to this would be like for an arbitrarily sized viewport. A general solution working this way for an arbitrarily sized viewport would be by far the most efficient way to do this. And I think it can probably be done with like a lookup table of some kind. But it'll be technically complicated compared to just casting rays. But that would be a mess, man. I don't think I drew that wall in the wrong place. The edge of the viewport should have been there. Duh. Sorry, I'm dumb. So yeah, I don't know, guys. The very specific solution for the 3x3 grid. I guess this is what we ought to go with, the way it's been done for now. And then when we want to try to make larger viewports, we'll figure something else out. I don't know, I'm just a dumb hick in a shack with some old computer stuff, so if you are a smart feller, and you can elucidate my dumb brain on the best way to do this for larger cases than the 3x3 grid, that would be pretty sweet. And if you actually watched this far, man, you're strange, but thank you. I love this game. I hope that we are able to get somewhere and do awesome things with it. All right, that's it for now. I'm going to go write some code to do this. And hopefully, well, no, there's a bunch of other busy work code I have to write first. We will probably not be able to explore dungeons by the end of the day, but I'm going to start on it anyhow. So, thanks for joining me, gentlemen and ungentlemen. See you next time.